Hi, for those of you that need a review or need to hear the lesson for the first time because maybe you were absent this day, we're going to talk about adding and subtracting polynomials. Essential question, how do you do that? And our learning targets are going to be finding the degree of a monomial, classifying a polynomial, adding and subtracting polynomials, and solving real-life problems. Now, this is the start of a unit, so you can see there's a lot of new vocabulary, and we're going to go through that. So a monomial is a number or variable or product of a number and one or more variables with whole number exponents. So these are some of the examples of what a monomial can look like. And this is what not a monomial looks like. So when I say not a monomial, I mean not a single term. A degree of a monomial is the sum of the exponents of the variables of that monomial. So for example, this is 0 because it has no variables. But this is 1 because there's a teeny little 1 here. So that's to the degree of the first power. This one, add them up. 1 plus 2 is 3. And this one is 5. So you can see how you can find the degree of a monomial. So if you're looking at the examples that we have here, this one is 2. This one, remember, this has a little teeny 1 right here. We just don't write it because as mathematicians, we don't do redundancy. So this is 1 plus 3. So 1 plus 3 is 4. This one is 3 plus 3. And so that's 6. And this one obviously doesn't have a variable, so this is going to be 0. This is going to be 4. Hopefully that you're finding this easier as I keep going. This one is 3 plus 2. So that's 5. This one has just got that little 1 right there. Don't forget it. And then this one obviously is just a number. So this one is just 0. So that's how you find the degree of a monomial. And we'll be using that a little bit more later. So polynomials are a bunch of monomials put together with addition and subtraction. And each one of these is considered a term. And when you have two terms, this is a binomial because bi means 2. And a trinomial because this means 3. So you have 3 terms. Now when you're writing these, the degree of a monomial, of a polynomial, is the greatest degree of all of its terms. So the largest one only. So when we write these in standard form, we do this exponent, 3, 2, 1, 0, and you can see they are in descending order. So from left to right, the biggest, the next biggest, and then always the constant term at the end. So this is a degree to the third. Leading coefficient is that very first number. Don't forget that number can sometimes just be a 1. So let's try it. We're going to write 15x minus x to the third plus 3 in standard form. Identify the degree and leading coefficient of the polynomial. So I'm starting with this. Now, do not forget that negative sign because that's its friend. It wants to come with it. So negative 3x to the third. My next highest is 15x. So plus 15x plus 3. This right here was positive. So that's why I made that 15x and not negative 15x. Now the degree is 3, the highest one right here. And the leading coefficient is negative 1. There's always a 1 in front of here, but in this case there's a negative as well. So that's going to be a negative 1. When you write these in standard form, always largest to smallest. So there's nothing else to write here. It is in standard form. I will rewrite it just for the sake of doing that though. The degree here is 4. This is a monomial, right? Because it's a single term. And this has negative 3 as its leading coefficient. Rewrite this one. You have 5x squared minus x, bring its friend with it. It's going to want to be there with them. And plus 4. This is to the second degree. We're going to be doing a lot with second degree stuff coming up. And this has a leading coefficient of 5, 1, 2, 3 terms. This is a trinomial. This is a binomial, 2 terms, but q to the 5th is their largest exponent, plus 8q. So this is in standard form. Your highest degree is 5. Okay? So write the polynomial in standard form, identify the degree and leading coefficient, and the number of terms. I would suggest that you pause the video for just a second and take a look at doing this yourself to make sure you got this skill. But I'm going to go over it in 3, 2, 1. So this is negative 9z plus 4. My leading coefficient is negative 9, and my degree is 1. Check your work as you're going. Hopefully you did this beforehand. Negative t to the 3rd plus t squared minus 10t. This leading coefficient is negative 1 with a degree of 3. And this one here is x cubed plus 2.8x. So my degree is 3. My leading coefficient is 1. Remember, there's like an invisible 1 right here. This was a binomial, trinomial, and a binomial. I know it didn't ask that, but just in case, might as well go ahead and classify that. So the set of numbers is closed under an operation when an operation is performed on any 2 numbers in this set results in a number that is also in the set. So it's considered a closed operation. So to add polynomials, you just add like terms. There's different ways of doing this. You can use vertical or horizontal. I don't really suggest vertical. It takes a lot to set it up, and it's actually kind of a mess after a while, but it's similar to 1, 2, 3 plus 1, 2, and you set them up with how they go as far as the number of exponents, like this could be to the 3rd power, to the 2nd power, to the 1st power, and setting it up, you could easily make a mistake because you might even have something like 4 over here. So this would be 4, and this would be 5, 3, 1, and you'd have a space right here with a null set. So don't do that. I really suggest using horizontal format or just combine your like terms. That's really all you have to do when you're adding polynomials. So if you're looking at this, you're looking at this going, well, I see 2x to the 3rd and x to the 3rd. So 2x plus x to the 3rd is going to be 3x to the 3rd. You're just combining those like terms. And this here is minus 5x squared plus 2x. So we're going to bring our friend with us, don't forget, because that matters. And you're going to have negative 3x squared. Plus x, notice there's nothing that goes with this over here to consolidate it with. That's what I was talking about when you might have something extra. And then minus 1. And you have not only put this in standard form, but you've actually added it all together. So you can almost just ignore the parentheses and do it that way. If you're doing this one, this is going to be x squared. So you're going to have 4x squared plus 5x plus 4. Notice this is a subtraction, so that's why this is plus 4. These x's go together, 5 of them, 5x, and 4x. Finding the difference is just slightly different. No pun intended there. But finding the difference is slightly different because all of this right here is being multiplied as if you have a negative 1 in front of a set of parentheses. So you got the set of parentheses with all these numbers in here, and you've got this negative 1 sitting here. Remember that everybody gets a car, and we need to distribute that. So what we do is we just make this addition. And as you do that, change every sign after it. So this becomes positive, negative, positive. And this is 4n squared plus 2n. So that becomes 6n squared. I don't have anything to combine with this minus 2n. Notice I'm doing this as if I'm doing it in standard form. And then 5 plus 4 is 9. Okay, again, change your sign and every sign in the parentheses after that. So you're going to end up with x squared, because this is a minus now, minus 3x plus x is minus 2x, and 13. Okay? Any questions on that? Please let me know. I know it's a little bit different. Right now, I would try these problems and pause this video for just a moment so that you can check your work. In 3, 2, 1. So right here, I have b and 4b, which is 5b, and minus 13. I did not have to change any signs. I just had to drop the parentheses and add the like terms. In this one, it's addition as well. So x squared plus 7x squared is going to be 8x squared minus 2x from right here and right here. They were both negative. Negative 1 plus negative 1 is negative 2, and minus 2. On these ones, you are going to have to change your sign. So just change your signs real quickly, and then now it's addition. And then you don't have to worry about any subtraction because it's all addition. So 5p squared plus 2p, and then notice that these cancel. So they're 0. I don't need to actually write 0. I just leave them out. Now, this right here, you have negative k, negative. Make sure you change your signs. So negative and negative make more negatives. Oops, I just made a mistake and nobody caught me because nobody's here to tell me. So this is actually k squared, right? So this is negative 3k squared, and then minus k and plus 11. Okay, so let's say that you drop a penny and a paintbrush from the height of a 200-foot building. Now, why you'd want to do that, I have no idea. But if you look at this picture right here, you can see that both objects got dropped, and they both have different rates of velocity and when they were dropped and time-wise and things like that. So they gave us these two equations. What they want to know in this problem, and you can probably see this on your sheet, is the penny is thrown from a height of 200 feet. At the same time, the paintbrush is dropped from the height of 100 feet. So somebody reached out the window and dropped the paintbrush. The polynomials represent the heights in feet of the objects after t seconds. Write a polynomial that represents the distance and interpret what the coefficients are. So we're going to look at this problem right here. We got this building with these two objects being dropped. When you're considering the difference between two things, you're looking at that space in between. This is the difference. So difference in math means subtract. Negative 16t minus 40t plus 200 minus negative 16t squared plus 100, and change your signs. Plus, plus, minus. So what you end up with is these two things right here canceling, and you don't have to worry about them. But you got your negative 40t, 200 minus 100 is 100, and that is the difference between the two. Now interpret the coefficients here. This right here is basically telling me that this is negative as far as the time goes. So as the time increases, the object is falling, and you have a difference of 100 feet between them, which is actually true. They were dropped 100 feet apart. So if you were to interpret this after, let's say, 2 seconds, you would just multiply, and you would see what the difference between those two objects was after 2 seconds. So like this, for example, would be negative 80 plus 100, and you can see the distance now is 200. Nope, sorry, 20 feet. I got overzealous writing my zeros. But 20 feet difference. After just 2 seconds, that paintbrush caught up to that penny. Or the penny caught up to the paintbrush. I can't remember which one was thrown first. The penny caught up to the paintbrush, or is catching up. So there's your lesson for 7.1. Please look at this over and over if you need to.